That would be my fear, but all right, it's time to resume.
Okay, Samuel, are you able to hear me?
Yeah, I can hear you.
Great. Okay, so let's see. I need to erase some stuff. All right, I have 3 problems today, which is a little bit ambitious. We might not get done with all 3, but I will upload all 3. But it's because we've had some canceled recitations. So I believe what I did is I tried to get us a problem for the principle of impulse and momentum, a problem for central impact, and a problem for oblique impact. So that's roughly what we're getting done today. Quick review of equations. This one here is the principle of impulse and momentum. And then, of course, if all of our impulses sum to 0, we get the conservation of momentum equation. And then, of course, last class, we talked about impact, and we talked about 2 different types of impact, one being central, one oblique. And both of these impact types require us to think about the principle of impulse momentum or the conservation of momentum in different ways and in different directions. So this first one here is a pretty simple problem. So I'm actually going to shut up a bit and let you guys work on it. But here we have a 20-pound block sliding down a 30-degree inclined plane with an initial velocity of 2 feet per second. Determine the velocity of the block in 3 seconds if the coefficient of kinetic friction between the block and the plane is mu k equals 0.25. And so one of the things that I want to reiterate, I'm not sure if I actually did a good job of pointing this out, but in the principle of impulse momentum, our indicators are slightly different than with work energy. With work energy, when we looked at a problem, and the problem was asking us about a change in velocity after some change in displacement, that was our indicator that work energy was probably going to be helpful. It's very, very similar for the principle of work energy. We're still talking about a change in velocity. That's a terrible highlight color. Change of velocity, but now we're talking after a change in time, right? Which basically makes sense. If you look at the work energy equation, work brings in a displacement in the actual equation itself, whereas impulse momentum, we're integrating over time. For impulse and momentum, we're integrating over time, so that variable time is naturally going to show up. Okay, so that's when we know that impulse and momentum is probably going to be helpful. All right, have fun. Right. Okay, so impulse and momentum, scalar equation or vector equation? Vector, okay. So we can look at individual components, meaning we can look in the x direction and then separately look in the y direction. Which direction would you like to analyze first? Why?
I think we're not solving like that at all.
That's okay. It's totally fine. Yeah. So how did you solve it?
I just did, I said f of y equals 0, solve my normal force.
You said f of y equals to 0 or the sum of forces in the y direction? Good. Okay. Yeah, absolutely. You could have done that. So you could have said the sum of forces in the y direction is equal to MAY, but this thing is not coming off of the slope. So acceleration in the y direction is 0. And we could have done that sum of forces equals N minus, I believe this is my 30 degrees. The y direction would be the cosine. So mg cosine 30 equals 0. Totally fine. But let's play around with this. Let's look at what would happen if we had used impulse momentum in the y direction. There we would have said mvy1 plus the sum from 0 to 3 of f dt equals mvy2. We would have found that the velocity in the y direction at time 1, what is that? Velocity in the y direction at time 1. 0. Velocity in the y direction at time 2. No, 0.
You're talking
It doesn't go in the y direction.
There's the x equal 9.
Nope. Oh, sorry, I forgot my header. Yeah, this is all y direction. Ah, that's another reason why. There we go. Okay. All right, and then 2 different ways we could do this. So here is our equation of motion direction, and this is impulse momentum. So we should get that we need to integrate from 0 to 3 all of our forces in the y direction, which would be n minus mg cosine 30 equals 0 dt. And these forces are all constant. Yeah.
You wrote 0.3 for delta t. I thought it was just 3, or is it 0 to 3?
0 to 3. Sorry. Thank you.
But
Wait, no, is it? Oh yeah, 3 seconds.
It's 3 seconds.
Yeah, 3 seconds. Yeah. Okay, so what happens when we integrate a constant? Multiply by time. So we'll get nt minus mg cos 3t equals 0. We can divide both sides by t. The t's cancel out, and I'm left with the exact same equation that I got from equation of motion. All right, what did we get for n?
17.32.
Very good. Pounds. Yep. Either way you do it, this is what you get. But kind of neat that you can use impulse momentum to get the same thing. Okay, so that's the y direction that helps us solve for the normal force, which we'll need in order to fully understand our friction force in the x direction. So it was a good idea to start with the y direction. Now we'll go to the x direction, where I have mvx1 plus the sum 0 to 3 f dt equals mvx2. Can fill out everything that I need here. So 20 over 32.2 times initial velocity in the x direction is 2 less integral from 0 to 3 of everything in the x direction. So I have a minus mu k n. It's my friction force. And then a plus mg sine 30 dt equals 20 over 32.2 Vx2, right? This is good news. One equation, one unknown. The one unknown is what it's asking me for. What do we get for Vx? 2. Say again? Sure.
I didn't use the,
Impulse momentum?
yeah.
What'd you do?
Same thing.
What'd you do?
Just solve for the forces in the x direction.
And then you integrated the acceleration? Totally fine. But you had to do an integration.
Yeah,
But we also had to do an integration.
yeah.
So 6 one, half dozen the other. Which makes these exams harder to grade. I have to do multiple solution guides so that I'm able to give points for all correct strategies. Okay, yeah, that's it. That's it.
Do you confirm that that's the right number? The right final answer?
Yes,
Okay.
Vx2 is 29.4.
I did the exact same thing and got something way different, so I need to redo it.
Yes. Yes, this is indeed what you should get. Make sure that you're using 20 for mg here. All right, questions? Okay. Let's do, the next two are gonna be impact problems. So we have two particles that are gonna run into each other. Here we have a ball hitting a block. So the 1 pound ball A is thrown so that when it strikes the 10-pound block B, it is traveling horizontally at 20 feet per second. Determine the average normal force exerted between A and B if the impact occurs in 0.02 seconds. The coefficient of restitution between A and B is E equals 0.6. So just a heads up that, well, let's look really quick. What type of collision are we working with here?
I don't know what it's called, but when they don't join together on them.
The non-oblique one, the central one. Yep, that's the one. Okay, so if I draw the center of mass of these particles, where I treat these two things as particles, and I draw the line between those 2 points, this is my line of impact. And if I draw the velocity before impact, I am along the line of impact. Okay, so the velocity is perfectly in line with the line of impact. So this is a central impact. So in our notes on this type of impact, we said you only have to care about one direction. And if you treat the particles as a system, then the internal impulse cancels out. So the impulse felt by the ball is equal and opposite to the impulse felt by the block, and they go away. So what you end up with is conservation of linear momentum along the line of impact. Okay. However, that's very, very useful if it's asking you what is like the final velocity of these two things, but it's actually asking you something different. What is it asking you for? It's asking about that force. Okay. So if you do conservation of moment, or sorry, if you do impulse momentum for a single object, like maybe just the ball, that impulsive force will be there, and momentum is not conserved for the ball alone. Okay, but it does reveal that force that we need to solve for. So the strategy here is going to actually be to first solve for the final velocities, treating this as a system of particles and using the coefficient of restitution as we normally do. And then separately, I'm getting so many spam calls today. Separately, we need to After we've solved for the final velocities, we then need to look at impulse momentum for a single object so that we reveal that impulsive force and we can solve for it. Okay, so do our normal central impact steps first, and then do this additional step where we analyze just impulse momentum for one object. Let me get this on do not disturb. Okay.
What they call this thing.
Not a single clue. It makes me really uncomfortable though. It's like a stone or a hand. Those make me uncomfortable too.
Oh, yeah, like the forces.
Uh-huh.
Stones. They're like
I don't know.
bales of hay.
It's like British way, isn't it?
I don't even know.
Okay, why?
Do you
Are we
have
assuming VB1 is 0,
of what?
the block?
Of the block? Yes.
Yeah.
Yep. Mhm. Yep.
I don't like the way the question is worded.
Yeah, I,
Cause it's.
it sounds like both of them
I
are.
know, cause it sounds about like once it hits them both.
Yeah, that's what I thought.
Yeah, it should say it more clearly that the block is at rest. All right.
Alright. Do you wanna know why it's called a stone?
Yeah, tell me.
It was named to invoke the concept of inertia or sluggishness, the resistance of a solid heavy object to acceleration.
This is why I hate American.
Crazy.
What's it say? Actually, paid for being here.
Oh man.
Said that?
No, but that's the not one of the ones, but. I don't know if that's a legit word, but just. Sure, something important.
You guys remember the coefficient of restitution equation?
I think I remember it. All right. VB2 minus VA2 all over VA1 minus VB1.
Yeah, the twos are on top. The ones are,
Like, what is that? Like, what is it conceptually? Is it how much the block is deforming and therefore absorbing mass? Is it how, like, is it like the coefficient of bounce, but it's like it will only transfer so much energy to the block? Like, what is the coefficient of restitution?
the coefficient of restitution has to do with the energy loss because of the collision. So there are lots of different ways that energy could be lost during a collision, right? Like there could be deformation, there could be sound, there could be thermal stuff going on. E just tells you how much energy was lost.
So if we have an E of 0.6, it's 0.6 of all of the energy, like we multiply, like
Was retained.
was retained. Okay,
Yes.
it was the amount of energy.
So perfectly elastic, you have exactly the same amount of energy going in as going out. E equals 1.
Can you scroll to the question up?
Yes.
Why do you cross off?
This, because for the system, the impulses cancel.
Oh, I mean, sorry.
Okay, so this should be V ball 2 minus V block 2 over V block 1 minus V ball 1. 0.6 equals
Assuming it's spread out throughout the entire question.
It's just like,
Which means your integration is straightforward if you're at still that's right.
assumption.
This was the part of the interaction. This is like energy.
I wish my physics experience was better, and not just like my first time teaching myself how to do something. That sounds awful. The first time like going to a college class and realizing the professor isn't teaching.
they think they're teaching. They think they're teaching.
So it's difficult to teach like 350 kids,
Yes, that is extraordinarily challenging.
and you're 80. You just focus on
There we go.
research. Like life's a little different, I think, at that point.
The funny thing is, at that age, they actually tend to give up on research and only teach. Okay, what'd you get for your velocities?
Negative 9.09 for the ball and 2.91.
Very good.
I figure in high school, this teacher had quite a lot of creativity.
You know, everyone in my high school was like, we all had to take like an extra like math or science course, and it was either between like physics or I forget what the other one was.
Bio or chem.
Yeah, or something like that. And I remember, I don't know if our physics teacher was just awful, but I remember everyone being like, don't take physics, don't take physics.
That's how I think you feel in my physics class my junior year of high school was 2 people. It was me and one other kid. We had to sit in another physics class and myself studying in the back of the class.
No.
Senior year was fun. We got a new teacher. It's got a teacher like outside. Like his class rate on APs was like less than like 10 years.
Okay, so this is the part that's new. So the question is not actually asking for these final velocities. It wants the force that's being integrated. So we need to then do impulse momentum for just the ball, which we can do now because we know this and we know this. We can solve for this in the middle. So that looks like the following: 1/32.2 times 20 plus f times 0.02 equals 1/32.2 times minus 9.09. So what do we solve for the force here?
45.12, -0.5.
Yes, it should be negative, you're right.
But if it's average, doesn't, because it depends on which thing you use.
It depends on which object, yeah. If it were the block, it would be the opposite direction. Yeah, but for the ball, I think you're right, it should be negative.
Can you explain why you're only doing it for the ball? Oh, that's,
No, is it
I think it just asks for average force, which I was,
average normal force exerted between the two?
so it doesn't really matter what sign
It,
in there.
it doesn't matter which one you choose because they're equal and opposite because physics. So I could have chosen the block, but the reason that I do only one is because specifically I don't want this impulse to cancel.
yeah, because I did it, all of it in the cancer. I was like, oh.
Yep, that's a problem.
So negative 45.2 and positive 45.2 would both be acceptable.
Yep.
Okay. Would it be wrong to just drop the negative sign because it's an average normal force and we don't specify on what object is acting on?
I mean, I specify here which object it's acting on, and then the values that you plug in for the velocities would also specify which object you're asking about.
Or like just looking at like the F, like if you read the problem.
Yes, just the final answer.
Just the, sorry.
Either one would be fine. Okay. We have 25 minutes. That's probably enough. All right, let's move on to another problem. Last problem. Two smooth discs A and B each have a mass of 0.5 kilogram. If both discs are moving with the velocities shown when they collide, determine their final velocities just after collision. The coefficient of restitution is E equals 0.75. Okay, so it actually shows us two different points in time. It shows us kind of like well before the collision, and then in the grayed out picture, it shows right at collision. So I'm gonna actually look specifically right at collision to draw the line of impact. So this is my LOI. But then my velocities are going like this and like this. Okay, so one of the velocities is not in line with the LOI. So we call this what impact? Oblique. Okay, so I would really like to take the training wheels off here, with full understanding that you probably need to look back at your notes to remember what to do for each direction. So let's practice that. I'm gonna stop talking, other than writing down the known and the find. Okay,
Okay, so it asks for final velocity, do you want it in like vector?
yes, yes, yeah, You need to tell me both an X direction and a Y direction, but it's gonna be easiest just to write it as a vector. Yep. Okay, did anyone have any issues with the X direction? So just as a reminder, the X direction, we basically treat the X direction as though we're doing central impact. Okay, so we do the conservation of momentum in the X direction for the system, and we use our coefficient of restitution equation. That lets us solve for the final velocities in the X direction. Then, who can remind me what we do for the Y direction
So
for each particle individually? Yep, very good. So Y direction. So there are no impulses in the Y direction for either particle. So momentum is conserved for particle A on its own, and it's conserved for particle B on its own. So particle A, VAY1 equals MVAY2. Well, particle A doesn't move in the Y direction at all beforehand, so it doesn't move at all in the Y direction after. Okay, so VAY2 is 0, and particle B. Masses cancel. Phew! Excuse me. 4 sine 53.13 equals VBY2. Okay, so then we need to put it all together. VA2 in the X direction, it's moving minus 4.9. Oh, sorry, 1.35. Sorry. 3.5 I hat. In the Y direction, A is going 0 in the J hat. The B2 is minus 4.95 I hat, and this comes down to 3.2. All right. Questions? Okay, I thought we wouldn't get through it all, but we got through it all early. So that's all I have for you today. If you have any further questions or clarifications, I'm here. I can stay until 11.
Could you go back to solving the X direction?
I sure can.
it's pretty much just this, and then rotate one and then impulse, and then we're done.
Let me pull up the schedule just so I don't misspeak. Okay, so Thursday, we're gonna start talking about angular impulse momentum for particles. And then the rest of the content will be all the same particle content, but for rigid bodies.
And then for the exam, it's cumulative, but like, will there be more of the new stuff, or is it kind of even split?
I'll say what I've told everybody else, which is theoretically it is cumulative in that I am wanting to test your understanding of everything we've learned in this class, but also recognize that I am very easily able to test earlier material by asking you later material questions.
Okay.
Does that make sense?
Yeah.
Cool. Thanks for being here. Sorry I was a bit late. Any questions, Samuel?
No, thank you.
Okay, cool.
For this question.
Mhm.
Solving the X direction, did you get, actually, right? BX2 equals negative BX2 minus 3.6.
I did not go through any of the solving of the system, to be honest. So if you did you arrive at these two equations?
I got the second equation. And I did the first equation, but then I solved for BX2.
Okay. Everything between there and here, it is just algebra.
Just to.
Then you have all you're doing is putting in reduction point, right? You
Yep.
don't want to solve for like the mag, like the.
No.
So to solve the two equations for two unknowns,
Mhm.
the how can you plug in one equation into the other if the only other thing that's being added to the equation is you have both bx2 and ax2 that are both not filled out in both equations. But so in the equation one, that first row, that's just filling in that what that bottom equation is, right? Because this is basically so. But
I'm not sure I'm following the question. So for solving a system of equations where you have two equations and two unknowns, you solve one equation for one variable.
Right.
Even though there is another variable on the other side, you leave it there. And then but you solve for that one variable.
Right.
And then you take everything that is on the right-hand side and you plug it in for that variable in the other equation. Then that last equation will only have that one remaining variable that you can solve for.
So for, when you're solving for the X directions, what I had done is I did the, what is this called again, the E equation?
Yep,
I
coefficient of
didn't-
restitution.
Yeah, I didn't think of doing the MV1 equals MV2 equation. Can I can do that because in the X directions, why can't I do that? Maybe I'm not, I
Be-
kind of understand it, but I,
Because I'm treating it as a system.
okay,
So this sum of MV1s means I have an MV1 for particle A
Yep.
and an MV1 for particle B. And the sum of MV2s means I have an MV2 for particle A and an MV2 of particle B. And treating it as a system means that impulse in the middle is also as a system. So we'll have an impulse that is applied to particle A due to the collision, and an impulse applied to particle B due to the collision. But those two things will always be equal and opposite.
okay.
Okay, so
makes sense.
because we're treating them as a system, those two things cancel. And I'm left with just MV1, MV2s.
Okay, that makes sense. So let's say if this was flipped 90 degrees, I
Uh-huh.
could use the sum to find it in the y direction.
This is why I've said I want you to,
Yeah, draw it out so I see like where the plane of impact and the line of impact is.
yes, so here's the line of impact. That always needs to be your X direction. This needs to be your Y direction.
Okay.
Then everything we've done is the same.
Yeah, that makes sense then. Okay. So I would flip the coordinate system instead of trying to flip that makes more sense actually.
Yeah. Yep.
So you went from, in the y direction at the bottom of the page, you went from like 0 to 3, n minus mg cosine 30 dt, and then you went to nt minus mg cosine 30t. So
It really should be, I left out that it should really be, this all evaluated from 0 to 3. But it doesn't matter because when you evaluate it at 0 to 3, you'll have n times 3 minus 0 minus mg cosine 30 times 3 minus 0 equals 0. So you'll still be able to divide both sides by 3. And it's no matter what, it reduces down to the same equation you would have gotten if you'd done equation of motion. Does that make sense? Okay.
I did that one instead of having it slide down to the left, I was having it slide down to the right.
Uh-huh.
But it's
Same thing. Yeah. It doesn't
Yeah.
matter. That's why they didn't provide an image, is it doesn't matter.
and then you use for the x direction, you use sine.
For the MG. Yep. So if I zoom in here and I break up my MG into a Y direction and an X direction, right? This is the one that aligns with the
Oh.
Y. This is the one that aligns with X. The X is opposite the 30, so it's the sine component.
Thank you, see you later.
You're welcome. See ya.
I only have 1 minute, but for problem 2,
Mm-hmm.
I got a little confused because if you scroll down, I think. For your restitution coefficients, restitution,
Yeah.
what I had was BB as being the block. So how did you get B as being the ball? Is that just
It doesn't matter. It doesn't matter.
And then you got -2. Should that be 20?
It should be block minus ball. I think you're right. I think you're right. Yeah, I think this needs to be 20.
I didn't know if you had divided by 10 or something.
No, it really should just be the initial speed of the ball. Yeah, that really should be 20. I'm sorry. That's my fault.
Okay. I think I had, well, on the first problem, I think I did my, originally I did my, coordinate system, like how you normally would do it, and that messed me up.
Okay.
And then that question, I didn't realize you could switch out the B and the A.
Yeah.
Or whatever you wanted, and then the two, but.
Cool. Yeah, you're welcome. Good questions. Great questions.